We left off last class. We were talking about solving equations, and we want to keep going with that today. I mean, we had some relatively complex equations, and we were working our way up to things that may have looked like this. Something like that. Now, this is way more complex than what we worked on last class, but it kind of puts everything together. Now, when we have an equation to solve like this, there are a few steps we should go through. The first step is to look at each side of the equation and simplify or combine anything we can. So what that means is we find our equal sign, and we can actually work on each side of the equation separately. So here on the left side, we have parentheses, and we're going to have other things we can combine. So let's go ahead and do what we can to simplify the left side. The first set of parentheses, anytime we see a parentheses, it should scream at us, do something here first. And there's two questions we need to ask with it. The first one is there anything that needs to be done inside that parentheses? Well, in this case, 2x minus 5, can we combine those? No, we can't. So we can't do anything inside the parentheses. So our next question is there anything that needs to be done to the parentheses? And in this case, it's being multiplied by the 3. So you guys have probably used the term distributing, as we mentioned before. You have to multiply everything inside the parentheses by that 3. So 3 times 2x makes 6x. 3 times negative 5 is a negative 15. Moving to the next set of parentheses. Once again, there's nothing that needs to be done inside the parentheses. So we're going to multiply by the 2. It's a positive 2. You have to be careful to make sure that whatever sign is in front of it goes with it. So 2 times 4x is a positive 8x. And 2 times 1 is 2. Now, before we do anything on the right side, we are going to continue to combine and simplify on the left side. What do we have there that we can still combine? Here, yes, we have the 6x and the 8x make 14x, and we can combine negative 15 and positive 2 to make negative 13. So we have 14x minus 13 on the left side. Now we'll go to the right side and try to combine whatever we can over there. We see the parentheses again, and there's nothing to do in there, so we're going to multiply by the 5. 5 times 3x is 15x, and 5 times 3 is 15. Then we've got a minus 43 over there. So then we go ahead and combine what else that we can. The 15x is going to be left alone, but we do have a 15 and a negative 43, which combine to make negative 28. So now we've combined and simplified everything we can on each side. The second thing we need to do then, once we've combined and simplified each side, is we need to get the variable on one side. Right now, the variable's on both sides. Now, in many of our equations we're going to solve, we don't have to do one or both of those steps. But in this case, the variable is on both sides, so we do have to get rid of one. Getting rid of the smaller one will be the 14x. To get rid of it, we will subtract 14x. That's gone, leaving us with negative 13. And on the other side, we have to take away 14x as well. We'll take it away from the 15x, which gives us 1x, or just x. And we do have to remember we still have the negative 28. So now then, solving that equation, and that's it. Once we've got those first two steps done, Step 3 is to just solve the equation. X has had 28 subtracted from it. So to solve it, we add 28. So negative 13, plus 28 is 15 equals X. So X is 15. Well, our main purpose for today then is to take these skills of solving an equation and apply them to problems, to word problems. Many of the word problems we work on are actually going to involve some pre-existing formula. And there are a lot of formulas that we might have out there, like total revenue. Revenue is just a fancy word for your dollar amount of sales. Total revenue is equal to the selling price times the number sold. An example of this kind of formula used in a word problem might be that Pete sells hats for $12 each. How many did Pete sell on a day when total revenue was $384? Now, many of you, on these simpler problems, it can be kind of tricky because many of you can probably read the problem and know just what you have to do to solve it. And you can do that without writing an equation. But I'm going to encourage you to try to write the equations just so you can get used to it, because as we get to more complex problems, having that decoding skill is important. I think that is one of the 2 or 3 most difficult topics to handle in math, is taking words from a word problem and create an equation that you can solve to get the answer. So here we do have that formula. Total revenue, which was the $384, equals the selling price, which was $12 each, times the number sold. We're going to let that be X. We're trying to find how many were sold. How many did Pete sell? So we solve this equation by simply subtracting 12. Or sorry, not subtracting 12. 12 is multiplying X, so we solve by dividing by 12. Gives us 384 divided by 12, I believe, is 32. Equals X. Now, with a word problem, we do have to make sure that we have answered the question. X equals 32. X was describing the number sold, and that is what we were asked to find, was how many sold. So 32 hats sold was the answer to our question. Another formula we might run into might be gross profit equals total revenue minus total cost. Now, here's a case where we're actually going to combine this formula with some other formulas, because total revenue we just saw was selling price times the number sold. Total cost is the same way. Total cost is the purchase price times the number purchased. Generally, when we're dealing, especially when we're dealing with gross profit, the number sold and the number purchased are going to be the same amount, because we're only concerned about the cost of the items that have already been sold. So anyway, using that formula, We might have a situation like Sam buys shirts for $8 and sells them for $15. How many shirts does Sam need to sell to earn a gross profit of $371? So here again, we have that formula, and I'm going to write it all out together. Our gross profit is equal to our total revenue, which is the selling price times the number sold, minus our total cost, which is the purchase price, times the number purchased. But remember, the number purchased is going to be equivalent to the number sold here. We're only worried about the purchase price on the ones that were actually sold. So now we look at what we know out of this information. The gross profit, we have a target gross profit of $371, so we're going to put that in there. The selling price is $15. We know that. We don't know the number sold. In fact, well, how many does Sam need to sell? That's going to be our X. Minus our purchase price was $8. And then the number sold again is going to be X again. So now that we've put the information into the formula, we can go ahead and solve. Now remember our steps. We can simplify or combine on each side of the equation. Well, we have 15x minus 8x on the right side. 15 minus 8 is 7. So that's 7x. And now we go ahead and solve. X is multiplied by 7, so we will divide by 7. Gives us 53. Now again, we need to make sure we've answered the question. And on some of these more complicated ones, it doesn't hurt to record what X stands for. Let's say X is going to equal the number sold. So if we recorded that at the beginning, we can come back and say, okay, X is 53. 53 is the number sold. Is that what we were looking for? Well, yes. How many does Sam need to sell? Sam needs to sell 53 shirts. Another formula that's pretty common might be perimeter. For a rectangle, you have the length, and you have the width. The perimeter of any shape is found by adding up the length of the sides. For a rectangle, you have 2 lengths, and you have 2 widths. So that formula is 2L plus 2W. We might have a problem given where with 90 feet of fencing, Kim wants to create a pen that is 9 feet longer than it is wide. Find the length and width of that pen. So here, it looks like it doesn't really jump out and say that we're dealing with perimeter, but we are because we're given total length of fencing, which will be the perimeter, the total perimeter of that when we're done. Now, if we look at this, we have two values we're looking for. We're looking for the length and the width. At this point, we don't know how to solve for two variables in the same problem yet. So we need to figure out how to combine that into a single variable. So there has to be a relationship between them. And the relationship is given further up in the problem here, 9 feet longer than it is wide. So what that is saying is if we know the width, the length is 9 feet more. So I'm going to make the width be W. And if I know the width is W, I can find the length is W plus 9 feet more. So now in my perimeter formula, the perimeter is replaced with 98. 2 times L, well, the length is replaced with W plus 9. Plus 2 times the width. Well, the width, we're just going to put in the W, so 2W. And now we can solve that. So again, we have to simplify or combine anything that we can on each side. Well, there's nothing to do on the left side here. That's going to stay 98. On the right side, there's actually a couple of things we can do. 2 times W plus 9. We'll do 2 times the W is 2W. 2 times 9 is 18. And then we still have the positive 2W there. We can combine the 2W and the 2W. So the left side is going to stay 98. 2W and 2W is 4W plus 18. Now we have simplified and combined everything we can. The variable is on one side of the equation, so we don't have to worry about that. So now we go ahead and solve. We subtract the 18 from both sides. 98 minus 18 is 80. On the right side, the 18 is gone, so we just have 4W. And we divide by 4. 80 divided by 4 is 20 equals W. So we got 20 equals W. And remember, W was the width of our equation. So the width of our rectangle, I should say. So that width is 20 feet. But remember, we have to make sure we've asked the question. The question said find the width and the length. So we need to find the length as well. W plus 9 will be 20 plus 9, which is 29. So the length is 29 feet. So we have to be careful to make sure we answer the full question. Another type of problem that involves a formula looks like this. When we have a solution, in fact, it could be a solution or just a mixture. There are 2 ingredients usually that go into that mixture. The first ingredient, if it's a solution, is called a solute. Second is called a solvent. The solvent is the bulk of the mixture. That's the largest amount. One example we'll use here, let's talk about salt water. We all know that if you put a small enough amount of salt in water, the salt kind of disappears. It dissolves. The water is the solvent. The water is the main ingredient. That's what you have to have the most of. The solute is the salt. That is the item that seems to disappear into that larger item. Well, to find the amount of that solute is actually usually usually what we consider the active ingredient. Since this is medical math, math for health professionals, we're going to be looking at dissolving medications into water, or dissolving medications into solution. That would be the amount of the medication. So we're very concerned with the amount of solute in a solution. So the amount of that active ingredient, or the amount of solute, is equal to the concentration of the solution times the total amount of the solution. Now, there are some strange things that occur as far as total volumes and stuff like that when we do solutions. We'll talk about that a little bit more later on in the course in Unit 3 when we talk about actual dosage calculations. For right now, we're going to keep it relatively simple. So what this means is if we have 200 milligrams of 7% salt in water solution, what that means is we have 7% is the concentration. The concentration is technically the percent as a rate or as a decimal. So 7% becomes 0.07 times, now I usually put the amount in parentheses, 200 milligrams. So we multiply that out. 0.07 times 200 is 14 milligrams. So the total amount of solute, or in this case salt, in that solution is 14 milligrams. It can also be done with water, with a volume or capacity. We might have, let's do this. If 80 milliliters of iodine is dissolved into 400 milliliters of total solution, what is the concentration? So here, the 800 milliliters is the total amount of that solute. It equals, we're looking for the concentration. So I'm just going to use a capital C for concentration, times we have 400 milliliters of total solution. I divide by 400 here. 80 divided by 400 is 0.2 equals C. So I have a concentration of 0.2, which I can list as 20%. Any questions so far? Okay. This one's going to be very important to us next week as we talk about mixture problems. That's one of the more difficult skills in this unit is doing the mixture problems. So anyway, let's talk about now some more complex word problems. We'll kind of work our way up to mixture problems. We might have something like this. Let's say Alex sells cups for $6 each, and bags for $15 each. Oops, Sam. Alex, I should have here again. Alex sells 4 times as many cups as bags for a total of $780. How many of each did Alex sell? So now here we do have two items that we're looking at. We have the cups and we have the bags. And we want to find the number sold for each of those. Well, the number sold here, again, we have two values. We got to find a way to relate them. We can't have two separate variables. So our relationship is right here, 4 times as many cups as bags. So what that means is we can calculate the number of cups from the number of bags. So we have to know the number of bags first. So I'm going to call that X. So the number of cups would be 4 times as many, or 4X. Then we need to figure out the total revenue. Because we're not told the total number of items sold. We're told $780. That's the total revenue in this case. So to find the total revenue, it is, as we saw up above, the selling price times the number sold. So for cups, the selling price is $6 times the number sold is 4X. That'll be 24X. For the bags, the selling price is $15 times there's X as the number sold, so that's just 15X. Now, I do like to do out a table just like what I did here because that helps me keep track of what I've done. And it also helps me once I have created the equation and solved it, it helps me put my information back in to actually answer the question. So what we have here, the 24X is the revenue from cups. 15X is the revenue from bags. We know that the total revenue is found by adding those together for that total of $780 of total revenue. Now we go ahead and go through our process. Are there things we can combine on each side? And yes, there is. 24X and 15X make 39X equals $780. So nothing more to combine. Is the variable on one side? Yes, it is. So now we go ahead and solve. We divide by 39 to get X by itself. X equals 20. Now it's really easy at this point to get excited. We wrote the equation, we solved the equation, we have an answer, but we're not done. We have to make sure we go back and answer the question. We were asked how many of each did Alex sell? Well, X represented the number of bags, that's 20. So there were 20 bags sold. Cups was 4X, so it's 4 times 20, or 80 cups sold. So doing a little bit of extra work up front to make sure you label what your variable is equal. And I do the table just because that's how I think. But you label what the variable stands for and then label what other things, how other things are represented with that variable. Once you solve your equation, it allows you to very quickly go back and answer the question. A little bit of organization up front saves a lot of work later. Now, this is an example of a specific type of problem where we have an amount A plus an amount B equals a total. There are other types of problems we'll run into. One of them is amount A has to equal amount B. Often this is where we find two different ways to express the same amount. In geometry problems, this happens a lot when you have two angles that have to be the same, and you solve to see where they are. Or opposite sides of a rectangle are labeled with two different formulas. You know they have to be equal, so you can set them equal and solve. Then, of course, the third option is amount A minus amount B gives us a known difference. And these two, the first one and the last one, can look very different, or can look very similar in the problems with just a couple of little things that make them different. So we have to look very closely to find those differences. So this next problem is going to be a little simpler than the last example, but the next couple are going to illustrate the difference between those two. So we might have Frank sells, let's say 3 times as many cars as Barney. If Frank sold 24 more cars than Barney, how many did each sell? So again, we have two different things here. We have Frank and Barney that we're looking at. And we're looking at the number of cars sold. And again, we have to look for that relationship between them. And we have it right in the first line of this problem. Frank sells 3 times as many cars as Barney. So what that implies is that we have to know the amount that Barney sold first. So the number that Barney sells be X. Frank sold 3 times as many, so that's going to be 3X for Frank. And here we have Frank sold 24 more cars. That is the difference between Frank and Barney. So Frank, number of cars that Frank sold, minus the number that Barney sold, is going to equal that 24 cars. Well, we have Frank sold 3X minus Barney sold X equals 24. It sometimes helps me if I label this as 1X. So I know when I'm combining here, 3X minus 1X, 3 minus 1 is 2, equals 24. So now that we've combined, we can go ahead and solve. We divide by 2 to get X equals 12. And again, we have to make sure we answer the question. We were asked how many did each sell? Well, X is 12, so that tells us Barney sold 12. Frank is 3X, so 3 times 12 is 36. Frank sold 36. Barney has 12, Frank has 36. Similar to that problem, though, we might have Kim sells 4 times as many cars as Stacy. If they sell a total of 45 cars, how many did each sell? So once again, we have two things we're looking for here. We have the two people, Kim and Stacy, and we're looking for the number of cars sold. Once again, one of them is calculated from the other. Kim is 4 times as many as Stacy. So if we know Stacy first, we'll let that be X. Kim is 4X. This time, the 45 is a total. So it's the number that Kim sold plus the number that Stacy sold. Gives us a total. Well, we already have Kim sold 4x, Stacy is x, adds up to 45. We can combine 4x and x. We think that is 4 plus 1 is 5x equals 45, and we solve. Dividing by 5. X equals 9. So again, we said that x was the number Stacy sold, so Stacy sold 9. 4x is Kim, so 4 times 9 is 36. Kim sold 36. Okay, so one final little type of problem I want to show you before we run out of time. In the case here, these last few problems where I've had two amounts, one of the amounts has always been a certain number times the other amount. But there's another way that can be a little bit more complex. Let's say that Pat sells backpacks for $10 each and hats for $5 each. Oops, 5, not 15. $5 each. Pat sells a total of 30 items for a total of, let's see here, $250. How many of each were sold? I'm just going to say how many of each. So here again, we have backpacks and hats. We have two things. And we're looking at the number sold. Now, there is a relationship between them, but it's not that one is a certain times the other. The relationship is there's a total of 30 items. So in this case, there isn't one that obviously has to be known first to figure out the other. So we're just going to pick one. We're going to let the number of backpacks sold be X. Once we know that, we can find the number of hats sold because it's just the total minus the backpack. So 30 minus X has to be the number of hats sold. But now again, we're not working off just the total number. We have to make that dollar amount come out. So we need to find a way to express the total revenue, which again is selling price times the number sold. So backpacks are $10 each times X, so it's 10X. Hats are $5 each times 30 minus X. So we're going to multiply that out. 5 times 30 is 150. 5 times negative X is a negative 5X. So now those two numbers, those two revenues have to add up that total of 250. 10X plus 150 minus 5X has to equal 150. And now we solve the equation. We're going to combine on the left side. 10x and negative 5x is 5x plus 150. I wrote that wrong. That should be 250. It has to equal 250. And we can subtract 150. So 5x equals 100. And now we divide to find the value of x. So we're going to divide by 5. X equals 20. So again, we have to go back and make sure we've answered the question. X was the number of backpacks, so there's 20 backpacks. Hats were 30 minus X, so 30 minus 20 is 10 hats. Okay, so The assignment I'd given you on Wednesday was page 49 through 50. 1 through 43, the odds. We covered that same material today, and we finished that material today. So for next week, I want you to look at those problems again. Make sure you focus on the word problems. Next week, we are going to spend some time on mixture problems, which usually does give students some trouble. So make sure you prep for those. Does anybody have any questions? Okay, well, you guys have a great weekend, and we will see you on Monday.